Have you ever stopped to think about what gives a tool its bite? I'm talking about the kind of tools that can slice through metal, press shapes into car parts, or survive the heat of a foundry without even flinching. There's something quietly heroic about these tools, reliable, brutally efficient, and oddly elegant in their resilience. The unsung hero behind all that strength? Tool steel. It's not your run-of-the-mill steel, and it definitely didn't just show up on the hardware store shelf ready to go. There's a science behind its toughness, and once you understand it, you'll never look at a drill bit or a punch die the same way again. So let's break it all down, right here, on History of Simple Things. To start, let's break down what tool steel even is. At its core, tool steel is a category of carbon and alloy steels that are specially formulated to be used for, you guessed it, making tools. But that word tools here means more than just hammers and wrenches. Think of cutting tools, molds for shaping plastic, dies for stamping metal, and high-temperature tooling for forging. These steels are engineered to be hard, wear-resistant, and capable of retaining their shape even after thousands or millions of repetitive uses. And unlike many materials that weaken under extreme heat or stress, tool steel leans into the pressure and keeps going. So what makes tool steel different from ordinary steel? It's all in the mix, literally. While all steel starts with iron and carbon, tool steel adds a handful of other elements that completely change the game. Chromium, vanadium, molybdenum, tungsten. These names may sound like items on a mad scientist shopping list, but in tool steel, they each have a job to do. Tungsten and molybdenum help the steel retain hardness at high temperatures, making it perfect for cutting tools that get hot during use. Vanadium increases wear resistance and strengthens the grain structure of the steel. Chromium adds corrosion resistance and helps form hard carbides, tiny microscopic particles that give the steel its tooth, so to speak. All of these elements are carefully balanced, and even a small tweak can dramatically affect the toughness, machinability, and wear resistance of the final product. Now, alloying is only part of the story. Tool steel's real toughness is unlocked through heat treatment. This is where the steel is taken through a series of controlled heating and cooling processes to rearrange its internal structure. It's a bit like baking a cake. Raw ingredients alone aren't enough. You have to treat them the right way to get the desired outcome. The process usually starts with austenitizing, heating the steel until it reaches a phase where its carbon atoms dissolve into the iron matrix. After that, it's rapidly cooled or quenched, often in oil or air, which locks the carbon atoms in place and hardens the steel. But that's not the end. Most tool steels are then tempered, reheated to a lower temperature to relieve internal stress and balance hardness with toughness. Without tempering, tool steel would be hard but brittle like glass. It's this dance of heating, cooling, and reheating that gives tool steel its almost paradoxical combination of strength and resilience. It's worth mentioning that tool steel isn't a single material, it's a whole family. Different grades and types are tailored for different jobs, depending on what kind of punishment they'll have to endure. For instance, there's cold work tool steel, designed to be used at room temperature for things like stamping, blanking, and punching. It's made to resist wear from repetitive impact and abrasive surfaces. Then you've got hot work tool steel, which thrives under heat, perfect for die casting or forging. It resists thermal fatigue and retains its hardness even when glowing red hot. And then there's high-speed steel, famous for cutting tools like drill bits and milling cutters. It can cut through other metals at blistering speeds without losing its edge. Each variety of tool steel is a carefully calculated recipe, designed not only for hardness, but also for how it behaves in real-world, demanding conditions. You might be surprised to learn that tool steel owes much of its toughness to its grain structure. Inside a piece of steel, the atoms form tiny crystalline grains. The size, shape, and arrangement of these grains determine how the steel will respond to stress. Fine grains are key. Smaller grains mean more boundaries, which makes it harder for cracks to spread. The heat treatment process and alloying elements like vanadium help refine this grain structure. When done right, the steel ends up with a microscopic landscape that resists cracking, resists deformation, and handles high stress like a champ. It's engineering at the atomic level, and it's one of the main reasons why tool steel lasts so long in punishing environments. But here's something you might not expect. Tool steel is also precise. It's not just about brute strength. Certain grades are designed to have very specific expansion rates, magnetic properties, or resistance to chemical corrosion. That means tool steel isn't only used in factories. It shows up in surgical tools, aerospace components, and even nuclear reactors. It can be ground to exact tolerances, polished to mirror finishes, or shaped into complex forms without cracking. In some ways, tool steel is like the disciplined martial artist of the metal world, strong, controlled, and extremely refined. Without tool steel, modern manufacturing would look very different. Everything from your car's engine block to the little socket your phone charger plugs into was probably shaped by a tool made of this steel. It's behind the scenes in almost every object we take for granted. That razor-sharp blade that keeps slicing after hundreds of cuts? Tool steel. The mold that gives your plastic bottle its shape? Tool steel again. It works in silence, takes the hits, and rarely gets the spotlight. But take it away, and the gears of industry grind to a halt. So next time you see a rugged tool or a high-performance machine part, give a little nod to the material that makes it all possible. Tool steel might not be glamorous, but it's the backbone of modern manufacturing. It's engineered toughness, sculpted by chemistry, and forged by fire. And while we often focus on the tools themselves, the wrenches, the blades, the dies, remember that the real hero is the material quietly doing all the heavy lifting. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.